Hey, hello everybody. Welcome to the DeCal. Today's Monday, March 15th, I believe. Thank you for coming if you showed up. We have a bit of a smaller class today, so hopefully more students will trickle in as time progresses. If not, then hopefully you're watching this asynchronously, and good luck with all your midterms before spring break. So let's just go ahead and get started with it. Today's going to be more of a short lecture. I have a lot going on with midterms. I'm sure everybody else does too. And the last bit of this lecture will just be like a little workshop to work on your final project proposals and whatnot. But yeah, I posted the attendance in the chat, and then I realized I did not update the slides. So give me one sec. Don't use this. That is not the right attendance form for those watching. It is this one. That is the right attendance form. Okay, cool. So this is the attendance form for those watching asynchronously. Those who are here synchronously, it's in the chat. Please fill that out. So announcements, final projects. Yes, communicate with your group members. They are due this Wednesday. Remember that. Final project proposals are due on Wednesday. Not the whole project, that would be ridiculous, but just a write-up saying what you're going to be doing. That is going to be due on Wednesday. Submit a PDF. We want you to LaTeX it, so it has to be done on LaTeX via Overleaf, preferably, so you can work on it with your partner. You don't have to stick with this project proposal at all. I mean, you can definitely change your mind if you find out that whatever your plan was way too ambitious, or if it was not ambitious enough and you get really bored, you want to do something a little bit cooler, then you can always change that too. But we recommend you stick with what you got, or just don't vary too far from it. So if your project proposal is on simulating a solar system, maybe it's not a good idea to just start working with Gaia data like 3 weeks or 2 weeks before the whole project's due. So just be careful. Don't completely change everything last minute. You don't want to pigeonhole yourself and then not be able to finish. So yeah, final project proposals are going to be due Wednesday. So please make sure you're working on them, talking with your partner, or if you're doing it by yourself, just make sure you get it all LaTeX in time. Cool. Today we're gonna skip a little bit of breakout rooms early on. We'll do more stuff later in the lecture, but I just have a little bit of something I want to show with you. It'll help you with your problem set 6, which is actually due on Friday. I want to make sure that you guys don't have any homework over break, because that's the worst thing in the world. So we're kind of rushing through. Apologize if it's a little stressful, but yeah, today we're going to be covering pandas. For those trickling into the call, there's the attendance link. Yeah, and so this pandas is a fantastic library. It's one of my favorite libraries for working with data. It makes everything else that we've showed you kind of a pain in the butt to work with. This is like bread and butter. This is what I use all the time when I have large data sets. Elon, for some reason, doesn't seem to like it because he's elitist or something like that. But I like this one. If you take data classes like Data 8, Data 100, I believe they use pandas as well. It's kind of like the go-to. It was developed by some people in Facebook or something like that. So yeah, it's one of the easiest ways to import data files, and it's one of the easiest ways to work with large amounts of data. So let's go ahead and get into it. How do you use it? Well, you have to import it just like any other package. We've talked about this extensively with SciPy, NumPy, with Matplotlib, and yeah, like in like other little libraries like random and math and so on. So you know the drill. Import pandas as PD. PD is the alias that we're making this whole pandas library usable as. This library imports data files with tremendous ease, storing them in a new data type. So this is a new type of data. We call it a data frame, which is just exclusive to like the pandas library. So Python doesn't actually have a data frame object or data frame data type built into it. Pandas is bringing that to the table. When you bring the whole pandas library with it, data frames come with it. So this is what it looks like. If you have like a data frame with some data, it has like columns and rows and names for each column and so on, and you can put different types of things in each column. And basically the way you create it is with dictionaries if you want to make your own. It's very similar to that, and I'll show you how to make them in just a little bit. But this is what it looks like, and it's a lot easier to read than like a giant NumPy array with like lots of commas and all over the place. It looks like garbage. This is actually readable. It's nice and it makes sense. So yeah. So let's use it to let's talk about how you use pandas to read in data. So to read in data with pandas library, you actually can do it very simply. It's kind of however you want to use it for whatever data file type you have. So in this case, in the first case I wrote, this is how you would use it for the context of reading in a CSV file. We worked with CSV files in your homework for some problem sets. They're my favorite type of file to work with because they're easy. It makes sense. They're separated by commas and that's it. So the way you would use it, use the pandas library, pd.read_csv. This is like a built-in function in the pandas library. And then literally it's as easy as just putting the file name. You don't even have to put any delimiter crap. You don't have to put any unpack crap. It just all that information is taken care of for you, and it just stores it in this data frame for you. So pd.read_csv, and you just put the name of the file and as the argument, and you get a nice little data frame that looks like this if your file is like formatted that way, which is really, really nice. Then, I mean, it's like once you kind of understand that line, then it's really, really easy to do anything else. If you want to use an Excel file for Microsoft Excel, same thing, but just instead of read CSV, it's read_Excel. If you have some sort of weird obscure data file, HDF5, well, you just look it up. You search like pandas import blank data file. If it's a .text file, if it's an HDF5 file, if it's a whatever ASCII file or whatever, pandas has got your back. They have lots of documentation, but you could just find whatever their function is. In this case, it's read_HDF for an HDF5 file. Don't worry about what that is. It's a little bit more complicated of a file that has lots of data for it, but it's pretty straightforward how to read in data. And then once you read it in, you can work with it. So if you want to get like, how do you extract like a column from this data set, right? So once we've imported this whole data frame that looks like this entire thing right here, this entire thing is a data frame. Let me get my laser pointer. This entire object right here, all these rows and columns is a data frame. So how do we take out like a specific amount of like specific column, and we want to take out all the values in that column? Well, it's pretty simple. You just index it by whatever the name of the column is. So you just say data frame, you index it by the name. So let's say, for example, on this one, if you wanted to get all the names, then you literally just put data frame bracket, comma, or bracket, like string names, and then close that bracket, and it would give you an entire column of all the names. Boom, just like that. And you have all the names, column values right at your fingertips. So if you want to make the data values a NumPy array, so this column values will still be a data frame, which doesn't necessarily work with every single thing. Like it might not work on matplotlib, it might not work in a curve fit function, but NumPy arrays do. So maybe you want to convert this column into a NumPy array. You can do that, super straightforward. All you do is whatever your column values are, this data frame that you pull out, you just slap on a $2.2_NumPy parentheses, and then boom, you're done. You have it. Now this column values is an array. It's a NumPy array, formatted just the way you want it. It's like a 1D array, so you can work with it nice and easy. If you wanted to make it a regular list, like in Python, you can do that too. .to_list. It's handled for you. It's as easy as that. That is all you have to do to convert it to a NumPy array or a NumPy list, or not a NumPy list, a Python list. So that's super straightforward. So far we've talked about how to import the pandas library, how to read in a data file using pandas, and then how to convert whatever data, columns and whatnot that you want into arrays or lists that you can use to do calculations with and whatnot in the Python environment. So now, how do you make your own? How do you make your own data frames? So you have to do a little bit of working around with dictionaries, but that's okay. So let's say you have some data lists or arrays. It could be either or, it doesn't really matter. I prefer to work with lists in this example just because they're basic, less writing. But let's say we have a list of names. We call them Jim, Dwight, Pam, Michael, Stanley. Okay, just a bunch of names, and then we have like birth counts. So in this particular example, I'm saying how many people are born with these names for some given year, whatever, it doesn't matter. So 9,837 people are born with the name Jim, 8,688 are born with Dwight, and so on. All these other names correspond to their corresponding name. And I want to put this all this information in a nice data type or like a data frame. I want it to just be like a nice little table that I can look at and say, oh, okay, well, there's this many birth counts for this name. How do you do that? Well, first let's make a data dictionary. Remember, we talked about this way early on in the semester. This data type is coming back to bite you a little bit. So here is how you construct a data dictionary. So it's initiated with this curly bracket instead of like a square bracket, or just a straight up parentheses for like a tuple or whatever. It's a curly bracket for a dictionary. And then we have our keys names, right? So whatever your key is, the string will be the name of that column. And then whatever the corresponding values are for that key will be a list or a NumPy array that will be formatted as the rest of the column. So this string names is standing as the key for this entire column values named or that are names. Same thing with the count. So if you, like in this case, if I go back, in this case count, right, this would be the string count. This is the key of the dictionary, and then all of these will be the values that go with it. Same thing with the names, and then the values of names. Cool. So that's how you construct it. So names and count are your keys, and they're denoted by strings. They have to be strings. And then names and birth count are the arrays or the lists that are corresponding to all the data that correspond to that column for each of those columns. So cool. So now you can do some data conversion. So, or like if you want to, this is a dictionary, remember, this is not a data frame, but if we want to convert it to a data frame, well, all you have to do is you just do pandas.data frame, don't forget the capitalization, and you just literally put in your dictionary. So data frame can just take in some dictionary of data, and it'll spit out a new data frame for you, a data frame object that you can work with. So this is exactly what last page, this is what this example's data frame looks like. On the left, this 0 through 4 is the indexing. You can almost ignore that. But you have a names column and a count column, just like how I mentioned earlier. These are the keys, and then these are the names. Like these are the data values that were a list that correspond to that key. And then these are the data, like the data or birth date counts or birth counts that correspond to each name, and those go in, like this was a list, and those correspond to the count key in the dictionary that is converted to a data frame. So great. Now we have this data frame. You could work with it just like how we had it before. So let's say you wanted to export all of this data into a CSV file so that your colleagues could work with it. It's simple. You just do df, right? Because I named this data frame df, but whatever this data frame's name is, .to_CSV, and then you just give it a name for whatever file name you want. So you make up this name in the notebook, and it will save a new CSV file with that name for you. And it's that simple. It's like, to me, it's like a cakewalk. It's the easiest thing ever. It's way more intuitive than any of the other libraries. So just to be clear on what we've done, Pandas library, import it. You can use it to read in data files. You can work with those data files by extracting certain columns and whatnot. You can make your own data by constructing a dictionary and then putting that in a data frame format, and it makes it all nice and pretty for you. And then all you have to do is just do a .to_CSV if you want to turn it into a CSV file. Similarly, there's like a to_HDF5, to Excel, so on, so on, so forth. All the different types of data or data files are available at your disposal. So sweet. That's it. Like that's all I got to say about pandas. That was super rapidly quick. Let's see. We're not even halfway through the hour yet. If you ever want to use it, this is how I recommend doing it. Try using it based off what this lecture says. If you get stuck or you want to do something but you don't know how to do it, you just click on this link. This is the full documentation. This is like literally 500 pages long or some stupid amount. Like how many pages is it? Yeah, it's like 3,000 pages. There's no way. Oh, is it really 3,000? Well, yeah, it's 3,000 pages. You obviously don't need to look through this entire thing, but it's all indexed and sorted for you. So if you ever had like any question for it, you could always look it up and be like here, and there's a lot more information that you'll ever need. Or you could just Google it on Stack Exchange. That also works too. but this is like written by like people from like Facebook and whatnot. So they're really good at coding and they're really good at documentation. So it's like super straightforward and ready to go for you. And that was all I had to show you on pandas. Does anybody have any questions on pandas? Okay. If not, that's totally fine. This will be on your homework 6 that is due on Friday. So this is like the whole second question after the AstroPi one. So if you ever have any questions, please feel free to just look at the slides. I'm pretty sure all of it should be answerable with just the slides, at least all the pandas related what stuff. So that's the new material. And then the old material we need to talk about is final project proposals. So I was anticipating more people showing up, but that's okay. We don't have to have everybody here. But what I do want to do is with the remaining time, let's say give it 15 minutes or so, maybe even 20, we can leave early. But I want to make sure that everybody who is here gets the help that they need, because I do understand that the final project proposals are a little short notice, like a week to make the whole thing. So I totally understand that, and we want to be here for you. So we're gonna stay. We'll do like 2 breakout rooms, maybe 3 breakout rooms, so that like whatever group is here or whatever groups are here, or if you're by yourself, we'll have like a staff help you. I believe there's three staff here, so we can do 3 breakout rooms and just help you guys with whatever your project is. If you have any questions with LaTeX, if you have any questions about the scope of your project, do you think it's doable? Then yeah, we'll be happy to help. And then if you're done already, if you've already written everything up, then this will be open office hours for homework 6. That's due Friday. So I hope that's a little bit of a weight lifter on you guys. We're not doing like a full lecture. It's a pretty short one today. And then Wednesday we'll share project proposals and whatnot. And then hopefully you'll get done with that. And then on Friday, homework's due and you have a free spring break to worry, so you don't have to worry about anything. But yeah, so we're gonna make some breakout rooms. I'm gonna stop recording and we're just gonna help you guys with final project proposals and homework 6 if you want. So let me just stop recording.